Okay, for question number 26, we are on to section C, and this section comprises short answer questions of 3 marks each. For the question number 26, first part, we have to evaluate definite integral 0 to pi by 4 log of 1 plus tan x into dx. So let's say it's our integral I, and we have to evaluate for 0 to pi by 4. This is log of 1 plus tan x into dx. Okay, now here first of all we are going to use the property it's 0 to a f of x into dx, which is equal to, we can write it as 0 to a f of a minus x into dx. So this gives I is equal to now 0 to pi by 4, and instead of x we are going to replace it with a minus x, and a is pi by 4, so this is log of 1 plus tan of pi by 4 minus x into dx. Okay, so now this is the formula tan a minus b. So tan of a minus b is equal to tan a minus tan b upon 1 plus tan a into tan b. Now, so I is equal to 0 to pi by 4, and let's consider this as our first set of equation. So this is log of 1 plus, let's use tan a plus b here. So this is tan a, which is pi by 4 minus tan b upon 1 plus tan of pi by 4 into tan b, which is x. Okay, now I is equal to 0 to pi by 4 log of 1 plus tan pi by 4 is 1, and tan x, which is 1 plus tan pi by 4 is 1, so it is tan x. Let's take LCM here, so I is equal to 0 to pi by 4, and this is log of 1 plus tan x, and 1 plus tan x plus 1 plus tan x, this gets cancelled, so finally this is 0 to pi by 4 log 2 upon 1 plus tan x. Let's say this is our second set of equation. We are going to add 1 and 2, so I plus I is 2i, and limit is same 0 to pi by 4, which gives, so the first set of equation was log of 1 plus, it was log of 1 plus tan x, so this is 1 plus tan x, and plus this is log of 2 upon 1 plus tan x. Okay, and now this is log a plus log, so log a plus log b, we all know it's log a. So 2i is equal to 0 to pi by 4, and this is now log a into b, so log a into b is log a, and this is b 2 upon 1 plus tan x, this gets cancelled, and we are left with 2, this is x. So 2i is equal to 0 to pi by 4 log 2 into dx. Log 2 is constant, so this is out, and now it is 0 to pi by 4 1 into dx. Integration of 1 is x, so this is 2i is equal to log 2, and x for the limits 0 to pi by 4, which is pi by 4 into log 2. And finally, I is equal to pi by 8 into log 4. So this is our answer. Let's move on to the second part. We have to evaluate the integral. It's input integral, so our integral is I is equal to integration of dx minus under root sine cube x into cos of x minus alpha into dx. Okay, we are now we are here going to make some adjustments because it's not in the standard form to be differentiated yet. So in this root, we are going to multiply and divide it by sine x, all within the root. So this is integration of dx, and this is integration of, we are going to multiply sine cube x into cos of x minus alpha. So multiply and divide by sine x. Now sine x into sine cube x. So this is now integration of sine raised power 4x into cos x minus alpha. And this is all within the root. Okay, now root of sine raised power 4x is sine square x. So this is integration of sine square x is out, and under root we have, so 1 by sine x. So this is cos of x minus alpha upon sine x. That is all within the root. Now sine square 1 upon sine square x, I can write it as integration of cosecant square x into dx. And I'm going to use the formula cos of a minus b here, which is cos a cos b plus sine a sine b upon sine x, and this is all within the root. Now, so our integral is now integration. This is cosecant square x into dx, and this becomes cos by sine is cot x. So this is cot x into sine x, and sine by sine gets cancelled. So this is only sine alpha here. This is under root. Okay, now it's now in the standard form where we know that the differentiation of cot is cosecant square, and we are going to assume this. We are going to make the substitution. So let's say cot x into sine x plus sine alpha is equal to 2. So differentiation of cot x, this is actually cos x by sine. This is, here it should be cos alpha. So this is cos alpha. Okay, now different cos alpha is constant, so it's out, and differentiation of cot is negative cosecant squared dx is equal to dt. Sine alpha is constant, so differentiation is 0. So that means cosecant square x into dx is equal to minus dt by cos alpha. Our integration after substitution, now this negative is out, and cosecant square into dx is dt. Cos alpha is constant, so it's 1 by cos alpha, and this is under root d. And we know that the difference in integration of the under root d is 2 root d. So this is 2 root d plus c. And finally, we can replace the value of d, which was cos x into cos alpha plus sine alpha upon cos alpha plus c. And this is our integration. Okay, so this solves our question number 26, and let's move on to question number 27.